string. I've created other large list of things to do. Have not ordered them. So yeah. Okay. I think I will start with this because it's quite easy to see, to work with. Let's start. Okay. Okay, we have our persistent term module, and I want to research about the put function. I have read a little bit about it. Okay. It is recommended to use keys to avoid name collisions. Before creating a few large persistent terms, okay, we have only one of them, or two. No. Instead of creating many small persistent terms. The execution time of storing a persistent term is proportional to the number of already existing terms. Okay, so if we have many terms, it will be more. It will take more time to write a new term. So it's better to, yeah, okay. So it's better to have small amount of large persistent terms. Okay, updating a persistent term with the same value is already has specially optimized to do nothing quickly. Okay. Thus, there is no need to compare the old and new values and avoid calling put if the values are equal. Okay, so I wanted to double check this thing. So this means if we have nothing changed, we can just put the same value and it will trigger no extra performance hits. So how does persistent term works? When I have read a little bit, okay, I have already read about it here. Okay, updating or deleting a persistent term will trigger a global garbage collector if the term does not fit in one machine word. Okay, I think it will not fit. Process will be scheduled as usual, but all processes will be made runnable at once, which will make the system less responsive. Okay, so when we update our persistent term, it will cause a garbage collector for each process. Each process will review whether it has one way to minimize the effects. Number of processes of the node before updating or deleting persistent term. Okay. To avoid updating persistent terms when the system is at peak load. So it's better not to update them frequently. Avoid storing a retrieved persistent term in a process if the persistent term could be deleted or updated in future. If a process holds a reference to a persistent term, when the term is deleted, the process will be garbage collected and the term copied to the process. Okay, so this recommendation tells that it's better not to store the value of persistent term inside the process. Okay, if the value will be deleted, the whole persistent term will be copied to the process memory. Okay, otherwise it is not copied. It's, as I understand, a sole reference inside the whole machine or node. Avoid updating or deleting more than one persistent term at a time. Okay, each deleted term will trigger its own global garbage collector. Okay, so we already have a mapper tuple. Avoid deleting or updating. Okay, storing a retrieved persistent term. Okay. Okay, so it's perfectly fine to have to call put value every time. Okay. Okay, I have checked it. The data mapping. Okay. Check for duplicate text. Can we remove text modules function? Okay. Check for reloading from IX recompile function, and check for reloading from Phenix code reloader. Possibly we'll start optimizing text modules again. Can we remove text modules function? Do we need it at all? Let's figure it out. I have a link. Tag. Okay. Interesting. Take module key. Register attribute and unquote. Just trying to take. Will it work? Okay, it seems it will work. So instead of it, unquote, take Okay. Okay. We'll replace other things too. Okay. And it will be our key and value tag. Code tag. Okay. Where does it contain? Defined module attribute. Okay. Interesting. Can we do something like this? I'm not sure whether it will work. And this home tag compile. Okay. Okay. Seems it works, but it's quite ugly. Just wanted to see how it looks like. Okay, so instead of this, tag, and here the tag to okay. Mm, tag. I think I will include. Okay. I think I will add this tag too. Okay. we have Elixir Home tag, and let it be like this. We have tagged modules. What I wanted to do is, can we remove tagged modules function? Tagged modules. Let's just remove it and try running our tests. Okay. So test don't depend on this thing. Compute tagged modules. We have this thing here. We don't need refresh tagged modules. Tag mapping. Okay. Compute tagged modules. Compute tag mapping. Okay. We compute and tagged modules. Available modules are these. So I want to use these things for some times. So it will be accessed quite frequently, because let me check. Okay, we can remove tag module functions. Okay, so what I want to do, I want to reload the tagged modules every time when something happens. For example, when I have thought about when I want to do this, I want to reload them or to compute mapping every time when I recompile the application. Okay. For example, when I recompile the application, I would like to make it to refresh the mapping, because okay, it's inside our development mode and it will be very useful. So it's one place. Another place is Phenix code reloader. Where is our Phenix code reloader? We have an endpoint here, and we have, okay, if we have code reloading, I'm not sure where it is implemented. Okay, if we have code reloading, then we connect to our live reload socket, we add our plug for live reloader. As I understand, it just injects some HTML parts that support reloading things, and also we have a code reloader here. At least I can add extra plug or something like that to reload my configurations, to reload the take nothing when the code reloading. Okay, so this we think is defined for our dev environment, so it can be called many times. So I would like our code to run as fast as possible. Okay, so that's why I will try to optimize this function again. Okay, but at first let's see whether we can add some reloading for IX recompile thing. As I remember, we can have this file. Switching to night mode. We can have this file to configure our IX session. And let's try adding it. So it can be placed in our home folder, home directory, or inside our project. Possibly it contains dot at the beginning. Okay. Let's see. I'm not sure whether it was called. Haven't seen any kind of good thing. When starting, IX looks for a local IX.exs file located in the current working directory. Let's check. Okay. Possibly it was not saved. Okay. Okay. We have our message. And that is fine. What will be if we attach a debugger here? It seems it doesn't work because possibly IX is not started yet. Okay. At least this kind of operation works. Import, we can load some file. Okay, import module from lib that may not yet have been defined. Print something before shell starts. Okay, we already have this. We can configure our IX. Returns registered software spawn, break, color, configuration. Interesting. What I want to do, I want to check whether I can overwrite my code or default AX function. Def. Let's try adding some function. Okay. And it should fail to start because there is no module. Okay. Module. Let's name it like helpers. Helpers. Okay. We have this thing. Import helpers. Okay. Let's check. Okay. Let's create another thing here, and where to? I will put it inside my inside somewhere here. Okay. X helpers X. Okay. Okay. Access home. Okay. Okay. Def is def. Okay. Yep. Okay. And we'll import it here. Import if available. Okay. Let's name it like this. Import if available. Access home. X helpers. Okay. And okay, it works. And then let's add something like a recompile and see how our IX will complain about this. Did it complain? Recompile. Interesting. Function recompile imported from both XS home and X helpers, and the X helpers code is ambiguous. Right. Okay, let's see about import. Okay, what are the options? Only split. Modules imported, and they both contain function. An error is only emitted is actually made. Okay. 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 So it's not an option. But something quite fun things. Okay. Super. The favorite. Okay. Mm, import. Okay. Do nothing. Do things. Okay. To summarize, in module whatever you only which has to close this. Okay. Not sure that it will work for our case. Interesting. Well, okay, can I override? Okay. I'm not sure that we will be able to add the function with the same name. Let me double check everything. If you import here functions and macros from other modules. Imports we can select only functions or macros. Only importing the same will erase previous imports. Lexical scope. Okay, we can do something with lexical scope. Okay. Okay, I think let's try just and let's try this. I'm not sure that it will help. Recompile. Okay. Here not include helpers. Okay. Okay. How not to include this file? It's Okay. Okay. So it seems it's not available. X import import. Do we have something like this? Start. Okay. I'm not sure that it's available for now, so we'll not work on this, for example, for at least for now. And I can remove X helpers module and our custom file. Okay, regarding this one, plug, how to write plugs for Phenix, plug. Possibly I can create just a function, def introspect. Okay. I will add a function with refresh tag. How did I call it? Refresh tag mapping. Okay. Refresh tag mapping, and it should have a connection and some options. Let's implement it. Tag access home tag refresh tag mapping and return a connection. Plug f refresh tag. Okay, so when we compile something and refresh our tag mapping, let's see whether it will work. Tag mapping. Okay, we have something like this, and possibly I will update it with something more. I will add I'm not sure. I will add extra tag SDF. Okay, let's do something like this. Okay, and here we have this thing. Let's remove SDF. It exists, but when I refresh, okay. I'm not sure what happened. Okay, leave it without any SDF thing. Let's refresh our page. So our application exited. Okay. It seems it was not so successful. It's a pity. Okay. Undefined function error. Function handler flow is undefined because there is no such module. Okay, last message tick. We have access to this message. And okay, we got some message. And after this, our application went down. It will be without any connection or something like this. Let's try refresh tag mapping. Refresh tag mapping. Refreshed it. Okay. Application works. Possibly it was due some other stuff. We compile. Okay. We have our service shut down because okay. Okay. So what does it mean? When we try to recompile and it gets too many of things and we have no such module or something like this, we end up with possibly, so I'm not sure. We have a message with tick. Okay, let's see our tick thing. So it seems like the application is shut down because our supervisor is not able to restart our client. Okay. Okay, where is this implementation? Clock. Okay. Not this, but service page 5. We have a handle info function which accepts module and value. Get an callback module, getting dependencies, updating them. Okay, it's not here, it's inside our clock service. Clock service is scheduling next tick. So we on a handle info with tick. Handle info, schedule next tick, and we're trying to we take refresh interval, send in this message, and working with update value. Okay. access home service, clock service, handle info. Okay, we have options. We're trying to dispatch some value. We're trying to dispatch a tick action to a module with this name. The module with this name, and it is not available during the recompilation time. Okay. It is not available because we are recompiling base modules. Okay, we're trying to dispatch to it, and it is not available, so it fails, and possibly brings down the whole thing together, the whole application. Let's check it. And things out. Observer, okay. Starting observer. Okay. Moving to the applications, we have our access home application. Okay, we already at it. Silence. Let's move back to the tag thing. Have config for our endpoint. Okay, we have a clock service here. So if it fails, access home supervisor will try to start it again. Let's try killing it. Okay. Killing it. It seems it was restarted. Okay, it was restarted. And okay, I have updated my code, but didn't call any recompile now. Recompile. Okay. Okay. I have brought down. Okay. So I brought down the clock service thing, and okay, I brought down the clock service thing. Where do we manipulate with it? We manipulate with it at our application thing. Okay, so this supervisor was not able to application start access home. Okay, brought it back. So there is no such module like clock service. There is no such module like clock service, and supervisor tries to restart it for a couple of times, but unsuccessful because there is no such module at the time it tries to do so. So it tries, for example, I don't know, 5 times or something like this. How much times? And dice. Elixir supervisor. And okay, Okay, functions, and good. Okay, we call in start link. Start link with options. Children options. Okay. Children, and the last will be option or init option. Okay. Option. Our option is only name. Okay. And init option is strategy, max restarts, max seconds. Max restarts. Okay. I'm not sure what is the value by default. And max seconds. Possibly. Okay. The time frame in which max restarts applies. Max restarts, so it tries to restart. It tries to restart 3 times for a time frame of 5 seconds. Okay, let's add max restarts 100. Let's try doing something like this. Next restarts 100 times within 5 seconds. And where is our tag? Okay. Tag. Recompiling. Okay. Okay. Our application survived. Let me check. Oh, no. It died. It's a pity. So what does it mean? Let's just close this thing. It means that it is better not to add some compilation time things like tags or something like that for a running system. So instead of both these things, we will just add about how to refresh a tag mapping. Okay, and I will mark those as completed. Okay, so if I will not be able to call those functions very much times, many times, I think it will be fine to not optimize it now. Possibly it will be in future, but for now it's quite okay to have such implementation as we have it right now. Inside, I mean this. So basically we run at least, so we can run this function a couple of times and it scans very much code, but it's more readable than useless optimization, at least for now. Okay. Possibly we'll add it later. Validate tag mapping, check for duplicate tags. Okay, let's move everything related to the tag mapping, refactor tag registry. Okay. Research when to refresh tag values. Okay. I feel not going to refresh it very many times. Okay, check for subscribe, extract dependency, link back. I think I will add another part. So we'll use this logic in preview because it will be more useful than trying to extract some extra logic to somewhere else. Add link, add home page live clock icon. Okay. Let's restyle instead of that. We already have it. Render preview for a service page. Let's do it like this. Next thing what I will do is to check for duplicate tags. What does it mean? It will be a part of refactoring of our code. I think I will make it public function. Just to be able to call it from test, something like that. We'll add doc. I'll add the specification for it. Just trying to think what I need to do. Okay, we have a module, we have a text. We have a module, we have a tag. Let's refactor it. And how to refactor this thing. Thinking about it. We have a module, we have a text for it. Tagged text. Okay. I will return module and tagged tags for module. Okay. Just thinking how to process it. how to approach to it. I have a list of tagged modules. I need to refactor this function. Okay, that's right. How can I test it? I have a limited set of modules. Compute tag mapping. Okay. Let's do it like this. I will add an extra parameter here. Okay. Just thinking how not to break everything. Let me create a test for this thing. It will be inside our Elixir Home web. Okay, here and tag test Elixir. Okay. Tag test def module Elixir home test tag test. Okay. Test. What I should test here? Okay. Computing text modules. Compute tag mapping. Refresh tag mapping. Compute tag mapping. Okay. Compute tag mapping. Okay. And others. Access home tag. Tag. Compute tag mapping. I think I will create we will make it public for now. Compute tag mapping, and we'll create another function. Def compute tag mapping. Tag mapping this params. Okay. Do and params. Compute tag mapping with so what should I expect here? The first thing will be it will be a list of tuples. The first thing here will be module 1, and it will be module 1, and the value will be tag 1 and tag 2. Take 2 is take 2 with some take 2 value. Okay, value 1. Let it be like this. And the second thing will be module 2. Module 2 with take 1 and take 3. Okay, take 3. Possibly take 1, take 2. Take 2 with a value of take 2 value 2. Okay, and take 3. Result. Okay. Result equals to what I will need at the end. We will need to have a take 1 and map to upset new from a list. And the first value will be take module 1. The second will be module 2. Okay. The next thing will be tag 3. 3 with map set that will contain only module 2. Okay. And the last thing here is our tag 2. It will be tag 2 value 1 with the value of module 1. Okay, and tag 2 value 2 module 2. And let's make it fail. Okay, it complains on the order of terms. Tag 3. Put in some comma here. Okay, that's all right. Okay. Let's make it work. Possibly the lot failed. params. Okay, we have it like this. Tag mapping, and I think I will create multiple tests here. And tag mapping. Yes. Duplicate. No. This string keys. These string keys. Okay. These string keys, tag mapping this pattern keys. So what have I done here? Checked for duplicate tags. Paste. This atom keys, and so instead of atom keys, I think I will this same key. This same key. Okay. For example, we have two modules and they share the same key. And it's not a nice option to work with. Check for duplicate tags. Okay. I think it will be this thing. Okay. Do you need to compile for files every time? Okay. I'm glad that no. Params. We have those params. Okay. I will unwind those things into a larger lists for module tags. For module tags. Okay, params. Okay, and tags. Look. Okay. We'll return a module. Case tag. Okay. Paste tag if it's atom, then this atom. Okay. We'll return type okay. Let's add another thing here, and mixed values. Okay. Type will be simple key. We will do tag value module. Okay, the next thing will be like this. It will be key for parent key and value. The child key. When is atom child key? Okay. I will return type nested atom up. Okay. We'll name it something like this, and key will be parent key and value nest child key and value module. Okay. I think okay. Parent key, child key, nested. If is binary. Nested atom nested. Okay. We have key tag 1, type simple, value audio. We have child key, we have key tag 2, and so on. Okay, that is fine. Tag nothing. Tag data. Okay. Okay. Let's call it tag data. Result will be tag data group by tag data. So we will group by our tag data by key. Okay, let's see what we'll have here. Okay. Result. We have a tag with this thing, tag to be this thing, and tag 3 with this kind of thing. Okay. what I need to check after it. I have grouped fake data. I have grouped the tag data by the key. Okay. The next thing I want to check whether all values inside the group share the same type. Okay. How to implement this? Key and do we have something like group by inside the for? Let me check this. Here for we have two options, other options. Okay, other options for we can filter the value, filter into unique, into and unique. Okay, reduce. No, I believe not reduce thing. Oh. Okay, so for key and values from our tag data or result. Possibly I will just pipe the result. It's not very readable. I think I will just reassign it. Take data do unless oh, what does it expect? Do okay, and where is our command thing? We have it here and functions. What I will need to possibly group let's see what we have. We can chunk by concatenate count return, deduplicate, drop every, drop while each, empty, fetch, find some index, frequencies, okay. Interesting. We can use it to find out whether we have mixed content here. Use frequencies, we can use group by, intersperse into, join, map, member, random, reduce, reject, split. You can split by some, and split this. No, not split. Okay. I think I can use unique by. Unique by. Unique values. So enumerate the enumerable by removing the elements. Return duplicate elements. Function fun maps every element to a term. Okay. Case in unique by values and we will pick a type. Okay. Case in unique by values. I think I will do it slightly another way. So what does return unique by? Okay. Unique by. So we take only first thing. Okay, let's try doing something. Case unique by values and function will get first parameter and type bool and okay. If we have single type, okay. Okay. And otherwise I will raise an error. Raise key is multiple types. Okay, let's do something like this. Okay, so it will be our type check. Okay. Or test again. Okay. Tag data. Tag data is working right now. Okay, we have it like this. So what I will need to return? I will need to return a map. Okay, for key for key values. Okay, for key values from tag data to end. Okay, let's pattern match on it. So what I will need here, and type. Okay, let's pick the type of first values here. Into the dictionary. Case type. And if our type is simple, then what I need to do, I need to convert everything that we have into a set. Set new. Okay. And values none up. Okay. Okay, I need the first argument here. Taking the first argument, if we have a simple thing, we will do something like this. Okay. Otherwise, I will convert those things to a map. Okay, how to convert them to a map? And values none map none map I will need some into a dictionary. Okay, first will be and it will be parent key. State values. Okay, let's do it like this, and then key state values. Okay, we have a parent key and value. Okay. And I believe that will be all for our case. Here, parent key not found. Okay, we have no parent key, we have only a key here. Okay, let's check result. In our result, we have take 2. So we comparing our tag 2. Take value 1, take 2. Right, it's that we expect. We expecting take value 1, take value 2, module 2. Interesting. Tag and module. Okay, we receive tag 2. Okay. Okay, so not a key. Okay, let's check it again. Okay, it works. Okay. Okay, compute tag mapping. It's much less than this thing, but we have some extra goodies, like validation. Okay. Okay. The next thing what I will try to do. I will also check whether all keys or all values if well, this not this this. Okay, so here we checked that we have unique type for all values. Next thing what I will try to do, I will try to check that we have this, we have different values here and different keys. Case. Okay, let's do it like this. Type, and it doesn't matter. What is else? What is other part? Okay, values. Case, type, and okay. If we have our type of input, unless none all, what do we have? All. Okay, we can all type. Okay, all values. Unified values, and here I will be value do base same module the module okay. Yes, multiple tag with name key with similar values. does it contain? Okay, the same error here. Otherwise, it will be string. It will be string. Doesn't matter. So it will be a dictionary. And it will be a dictionary, and I need to check that child key is different. Shuffle, shuffle. Let's check that every value is different here. Frequencies by values. Value. Um, num any. Mm, then okay, is it container? Possibly you need to add some parentheses here. Mm, those things will be what unique values. Mm, Not key frequencies by zero based, not, and first parameter, then zero. Values. If we have non-unique values, key has non-unique values. Unique values. Okay. Okay, let's analyze type. Simple. If type not equals simple, do okay. What I will do here, if tag not equals simple, then we have child key everywhere. Okay, non-unique keys. Okay, what I will do here, values, non. Okay, let's do just the same. One. Okay. Let's duplicate his unique. Possibly I will name them like duplicate. Okay, it seems I have removed our type. Okay. Let's duplicate. Okay. You take modules, then I think we will def validate take data. Data. Okay. I think I will move it to this function. Okay, tag data. We'll run the tests. Okay. Okay. Okay, we have tech modules. I think we will move it a little bit upper. Should take mapping and compute take modules. Modules equals this thing. Compute take modules. Okay. And mapping modules. Compute text modules. Compute text mapping. Compute text mapping with params. Okay. So what I need to do here is to return in such case module and tag x module. Okay, and it should work. Okay. Should work without this function. Okay. And we have some parts not covered. Okay. Let's cover it. The result. We have correct result. Let's format. Tag mapping with string keys. The result will be tag compute tag mapping. Do we have? Okay. Compute tag mapping with this thing. Module 1 will be tag mapping with string keys. Okay. It will be tag 1 or okay. Module 2 will be tag 2. Okay. Insert result. Let's check that our result will be tag tag 1. Okay, tag 1 will be module 1, tag 2, module 2. Okay, we have pre-filling tests. Tag 1 is tag 2 will be this. It should work too. It works. Tag mapping with same key with mixed values. This I think I will add with duplicate. With duplicate values. Result will compute tag mapping which should fail. Can it convert strings? Get representation, good thing. Okay, that's fine. Compute tag mapping, where can we has non-unique values. Validate tag data. Validate tag data, line 125. Okay, here's duplicate keys. What? Okay, inspect duplicate keys. So it should work now. Tag has duplicate keys tag. Okay. Set trace. Set trace function. Exception and function. Error. Okay. Let's duplicate values. Okay. Takes mapping with same key. Let me check this. This duplicate keys. Duplicate values. Okay. Let's check a set trace. Runtime exception and something like this. Runtime error and so something duplicate duplicate keys and something else. It should was okay. Process. So I will borrow it to here and duplicate values. For example, we have module 1 and module 1. Okay. Let's duplicate values. Inspect. Okay. Okay. Okay, what is okay? We have returned almost to the same coverage thing, and mixed modules, mixed values. Okay, take compute mapping. Module 1 will be take, and another module will have only a take thing. Okay. Okay. Please check the given list of call inspect. Okay. So let's types will be data none not okay. Mixed type in modules and modules and data and value. Okay. I need to add some spacing here. Let's check. And the last thing is select. Thing, set trace, and use mixed types. Mixed types. Okay, now our tests pass. And I'm glad about this. Okay, validate mapping. Let's review current diff. Okay, what have we added here? We are quoting. We add an extra tag. we're adding extra tag here. Also, we have extracted the commutation to own module, to own function, and made it more testable, just to check that it works correctly. Also created a test for it. Let's run mix format. Let's have mixed format here and git commit. I think the leader will be happy. Okay. Creator is happy too. And text tests passing. And take the registry and it is test. Okay. Checked for duplicate text, validated for tag mapping, refactor text registry. Okay. Okay. Yeah, it's quite a large piece of code, especially this compute tag mapping. It contains more code right now. It contains more code now. I'm not sure whether it's more nice to see or more readable. Interesting. Okay. So it works. We have some validation. It's kind of readable. Not perfect, but at least works. Okay. So I think I'm happy with it. Let's check that everything works. Okay. It seems it works. We can move here and move back. Let's pick a dark theme here. I think I will add some. I will add small modification here. Service preview. Service preview. Where is my service page? Okay. Okay. Create tag. Include prefix. I think I will do something like this. Prefix. Okay. work now. Where is imported? Okay. We fixed this. Okay, clock not found. Okay. So it's our service page preview. And okay, it should work. Okay. So we have something like this. We have preview and clock. Where is my service page thing? Service page, tag mapping, service pages. Service page live. Or I think I will just do something like this. Up values. Okay. Compile. Okay. We have set of services and so on. So instead of this, I will so let's keep it now. Committing those things. Use string keys for use string keys for string keys for service page preview. Okay. chapter, circular dependency, reuse, service page logic and preview, explore, subscribe, dependency management. Okay. I think it will be all for today. Plan to continue tomorrow with more refactoring, more things, and yeah, some other stuff. Possibly I will get some new ideas what to do and how to do it. Plan to continue tomorrow. Thanks for watching. Bye.